All right, welcome to day 6. Couple things to think about for homework. You got your regular homework packet page 32 and 33. And if you have not done your problem set yet, the problem set is due next class period. So for each of those, the day they're due, so the next school day is when they're both due. Remember, they have to be uploaded by 5 a.m. that morning. So you can't wait till that morning to do them. It needs to be the night before at the latest that you're uploading them. Remember, you can be stopping by office hours during ninth period if you have questions on either of those things, so you can get them answered. All right, so looking at our warm-up, we want to see if this can be accurate, yes or no. Well, we have angles on a line. We know that angles on a line should add to 180. If we add these, they add to 190. So this one would be a no. In 2, we have AB is perpendicular to CD. What perpendicular means is they should form right angles. So this should be a right angle here, and all 4 of those will be right angles inside there. So knowing that, this should add up to 90 as well. So if we do that, 48 plus 42 will give you 90 degrees. So this one looks like it could be a possibility. All right, let's look at the homework. Now in the homeworks, it didn't say you had to justify the geometry steps, but I'll just say what they are as we're going through, because sometimes I will ask for them. So they have our picture there. We know that a midpoint implies 2 congruent segments. That's why we set our parts equal to each other. Get x equals 3, sub back in to find the AY. Remember, if you need to copy down and fix anything, just pause the video because I'll keep going on. So we had already had our picture. It had the 2 marks on it. That told us that we knew they were equal. So we set the 2 parts equal to each other. Our geometry justification would be midpoint implies 2 congruent segments. Solve for x, get 22. Sub it back in to find what PT is. Here we had 1 mark on these ones, and we had 2 marks on those ones. So if AD is 12, we can set that equal to the DC because they have the same marks. So this is our midpoint implies 2 congruent segments again. We get Y is 13. So C is essentially showing the segment subtraction postulate. If you take the whole thing minus one of the parts, it should leave you with the other part. So notice they said nothing about a midpoint here, and they said they wanted us to use the segment subtraction postulate. So take the whole thing, the 42, subtract one of the parts to get the other part. Now I chose to subtract the 2x plus 8. You could have done the x plus 4 and then had the equal to 2x plus 8 over on the right. Either way, you should get the same answer. The x is 10. All right, in 6, they also wanted us to use angle subtraction postulate. So take the whole thing, the GAM, and subtract one of the parts. I chose to subtract the 6x plus 17. You could have reversed which one you were subtracting and which one it was equal to. Either way, you would have went through and factored. We get x equals 10 and x equals 2. Remember, when that happens, just make sure you're getting positive values there, something that would make sense. Now, GAE could end up being 2 different things based on our x values. You could either get 77 or you could get 29. All right, so today is going to be a bunch of definitions, and we'll do a little bit of practice towards the end. So we're starting on page 28. So if you could be on page 28 in your packets. So an angle is formed by 2 rays with the same endpoint. So something like there's a ray, so it forms an angle. So the rays are the sides of the angle. So you can fill that in the blank on your notes. whereas the endpoints are the vertex. So the corner point of the angle where it's pointy, that is what's called the vertex of the angle. You can kind of think of it makes a V there in a lot of angles. So therefore, it's the vertex. Naming an angle. So sometimes an angle will be numbered. So this angle here we could call angle 1. If there's only one angle going on at the vertex, so our vertex here is B, then you can name it with a single letter. So we could call this angle B. Or you can name an angle with 3 letters. Now notice when we're naming these, they're capital letters because points are always with capitals. Now when you name it with 3 letters, you need to make sure the vertex, the B, is in the middle. So we could call this angle TBQ, or we could call the angle QBT. Any of those 4 would be correct. Now when we move over to the right, if we want to talk about the big angle, we would only have 2 ways to name it. We could call it RTL, or we could do LTR. We could not do angle T. Okay, angle T would not work, and the reason being there are multiple angles at that vertex T. Over on the left, there's only one angle at B, so that's why we can just call it angle B. But you cannot call anything just angle T because there's really 3 different angles that are going on at angle T. All right, going down to the bottom, an acute angle is one that goes from 0, or is in between 0 and 90 degrees, so you can fill in those blanks. A right angle is one that equals 90 degrees. An obtuse angle is one that's between 90 and 180. And this is probably one that's least familiar to you. A straight angle is one that is equal exactly 180. Angles with the same measure are what are called congruent angles. You could say their measures are equal, or you could say the angles are congruent. So we would say if measure of angle 1 is congruent to angle 2, then we would say angle 1 is congruent to angle 2. So congruent symbol is the equal with the squiggly on top. And the marking to show that angles are congruent, you do the same number of arcs. So if we wanted to show 1 and 2 are the same, we could go like that. Or if we had multiple ones we could do, you could do like 2 arcs. So just like the markings on the lines, any that have the same number of marks are congruent. With angles, we would do the little arcs to show congruent angles. Moving to the top of page 29, next we'll talk about vertical angles. So vertical angles are angles whose sides are opposite rays. So basically, if we look at this picture here and worked with angle 1 and wanted to know its vertical angle, we'll just take the sides of angle 1 and keep on going through, so its vertical angle would be angle 2. And then we could do the side ones too, angle 3 and angle 4. So if you want to know if there is an angle that is vertical to any angle, follow the sides of that angle through to the other side. Whatever angle that opens up to, those are the angles that's vertical to it. So to mark these up congruent, we could maybe put like 1 arc on these, and then we could put 2 arcs on the other ones. Adjacent angles are 2 angles in the same plane, so coplanar, and they share a side and also share a vertex. But there's no interior points that are the same. So here's 2 different examples of adjacent angles. Adjacent means next to. So 2 angles that are next to each other, and they've got to share a side and a vertex. The sum of 2 or more adjacent angles that form a straight angle, so a straight line, is 180 degrees. So our justification when we do our geometry steps will say something like angles on a line sum to 180. Or you can say angles on a line equal 180 degrees. That would be fine as well. So here's like an example of that. Let's say we had this. We would know that angle 1 plus angle 2 plus angle 3 equals 180 when we set up our equation, and our justification would be angles on a line equal 180. We're going to use that one a lot. Okay, so if you want to star that one, that might be a good one to star. The terminology on the bottom, I think you did in middle school. First one, complementary angles are two angles whose measure have a sum of 90. Notice it's just a pair of two angles, and the angles are called complements of one another. So in that example there, 40 and 50 would be considered complements of one another, angle A and B there. And on the left, there's just a picture showing that when a right angle gets split, it creates two complementary angles. The other one is supplementary angles. So those add to 180. Now, when I was in school, the way I remember the difference between them is alphabetically, complementary C comes before supplementary S. And when you're counting, 90 comes before 180. So the ones that come first go together, and the ones that come second go together. And each angle for the supplementary ones are called supplements of each other. And there's two examples there. So now, supplementary versus angles on a line. Supplementary angles are just any two that add to 180. It doesn't have to necessarily be adjacent. Angles on a line must be adjacent to each other, and it can be more than just two of them. So again, supplementary are just any two angles that add to 180, don't need to be adjacent to each other. All right, so if we go to the next page, page 30, we can do some naming practice. We want to name this in three ways. Now there's actually four ways. We could name it angle 1, we could name it angle C, because C is the only angle at the vertex. We could do angle MCP, making sure the vertex in the middle, or angle PCM. So again, that's four ways to satisfy the question. If that was on a test, you would just have to do three of those four. So we want to name angle 1 in two different ways. Well, our options are keeping the B in the middle, ABC, or we could do angle CBA. You could not do just angle B because there are multiple angles happening at vertex B. On the bottom, we're going to draw and label some things. An obtuse angle, so that should be between between 90 and 180. So RST, so I'm going to put point R here, S there, and we'll put T there. Acute angle C, so it should be something between 0 and 90, and we can just label a single letter C. Straight angle EFG. A straight angle should just be a straight line. So we got E, F, and G. And a right angle. This angle I've currently drawn is not a right angle. The only way to know it's a right angle is if they actually tell you with the box. You can't just think it looks like it because maybe it's 89 degrees instead of 90 degrees. So the box is what tells us it's the right angle. So maybe we'll put G there. H has to be at the vertex, and then I. All right, we'll do a little bit of practice actually solving some things on the next page. So we're going to find the variables, and then we're also going to justify our steps. So what we'd want to do is we'd want to do 97 plus b plus 36 equals 180. And our justification, we would say angles, and you can abbreviate angles with the symbol, on a line equal 180 degrees. So if we combine our like terms here, we get 133 plus b equals 180. Subtract the 133 over, and we get that b is equal to 47 degrees. Similar idea over here, we can do 40 plus 36 plus c plus 90 equals 180. We would again say angles on a line equal 180 degrees. We could combine our like terms, and we'd have 166 plus c equals 180. And we can subtract the 166 to give us c equals 14 degrees. And our last one for this video, we're going to solve for x. Now they gave us AOC is 7x minus 2. So this whole big angle is 7x minus 2. AOB, this one here, is 2x plus 8. Well, notice it had that red marking on it. So that tells us we also know this one is 2x plus 8. And then BOC, so this one right here is 3x plus 14. So we've got to figure out some relationship to figure out what x is. And if you notice the top green one, the 2x plus 8, and the purple one, those are the two small parts that should add to the 7x minus 2. So we can do 2x plus 8 plus 3x plus 14 equals 7x minus 2. And our geometry steps that we need to justify is the angle addition postulate. Again, if you want to abbreviate angle with the angle symbol, angle addition postulate. So now we can combine like terms. We got 5x plus 22 equals 7x minus 2. Maybe we'll add the 2 over. We can subtract the 5x over. And we'll divide by 2. And we'll get 12 equals x. Now remember to always reread the question, see if that's what they're looking for. We want to solve for x. Okay, so we're done in this case. About half the time you'll be done, about half the time you'll have to sub it back in. All right, so remember you got your regular homework and you got your problem set. You got to make sure you have those submitted by 5 a.m. on the next school day. Post any questions you have either in the content discussion board or join the 9th period office hours.